Okay, so for each molecule, what is the polarity of the bonds and the overall polarity of the molecule? So we can't see all the molecules there, but I'll go through them. But I'll draw them as I go through them. So, so our first one is CH2Cl2. So if we draw this guy, so it's going to be a tetrahedral shape where I'm using the wedges to show it's coming out of the board and the hash to show that it's going into the board. I guess I should use a slightly more appropriate convention than I've been in the past and draw my dipoles from negative to positive. So here we would have a dipole. Here we would have a dipole. Although you will get a minor dipole from carbon-hydrogen bonds, it's definitely not going to be as high as for carbon-chlorine. Which means that, and because this is a bench shape, so if I kind of tilt this like this, then our hydrogens would actually be more like that. And these are now coming out of the board because I've rotated the molecule. So if we look now, we can see that we're going to get a net dipole in that direction, basically. And so CH2Cl2 is polar with the net dipole basically into the page as I've drawn it in this image, but a little bit up. So similar to water, basically. Where these hydrogen atoms are basically where the lone pair would be. Okay, so for HCN, again, our hydrogen-carbon bond is going to be a minor contributor, but the nitrogen-carbon bond is going to be polar. Meaning our net dipole, and in fact this would be a minor one that way, our net dipole is going to be along the nitrogen-carbon bond, but to the left. And then for our third molecule is H2O2, which is kind of a funny shaped molecule because it does this, where the wedge is coming out of the page and the hash is going into the page. Or if we tilt it 90 degrees so that we're looking at the oxygen end on, then we would have something that looks pretty much like water. The only difference is that this hydrogen is actually displaced into the background, but also similar to water, we've got two dipoles, and so then the net dipole is actually going to be pretty much straight down, which cuts the molecule in half. Okay. Okay, so for a bond to be polar, the difference in electronegativity, so this is, I guess, more of a numeric definition. So CH bond is technically nonpolar, as I said, or as I basically indicated by having these smaller arrows, whereas a CCl bond is definitely polar. So for our first molecule, we get two large dipoles for carbon chlorine, and then we're going to get a net dipole because of a lack of cancellation. In HCN, we again have no dipole with the hydrogen, but a dipole between the carbon and nitrogen, giving us a polar bond. And then in H2O2, because of this tilt, we're going to get dipoles in the OH direction, and it's going to be a polar molecule. So that looks good.